Hi everyone. Yeah, I'm Ravi Shankar Joshi, one of the mentors for the DSA learning series that we are running for GEC Bhavnagar. And I'll talk about a few tips and tricks which can help you solve DSA questions on online coding platforms such as CodeChef, Codeforces, etc. So let's get started. First is time complexity. So time complexity is one of the most basic topics in DSA which you should definitely know well, and you should learn big O notation. And let's talk about what does it mean for a function to be big O of 2 to the power n, big O of n square, big O of n, big O of log n, big O of 1, etc. So a function is called if a function f of x is called big O of g of x if f of x is less than c times g of x for all x greater than x naught. If f of x is upper bound f of x is upper bounded by g of x for all sufficiently large at x, it shows that the order of growth of the function f of x that we are talking about. So we have shared a few resources on the DSA learning Facebook group to learn the time complexity and big O notation. Please go through them. And we when we want to compute the big O notation time complexity, we drop all the constant terms. So let's say if the function is f of x is equal to 2x cubed plus 4x plus 5, we say that f of x is big O of x cubed. Typically, the DSA coding questions are set such that only the solutions with the optimal time complexity would pass. So, if the so let's talk about what is optimal time complexity. So let's say you are given some question which just asks for, you are given an array and you have to sort it. So we all know that there are O of n square sorting algorithms like insertion sort and selection sort, but then there are also O of n log n sorting algorithms like merge sort or quick sort. So if your sorry, wait, I made a little mistake over there. So quick sort is worst case O of n square and average case big O of n log n. So if the question is set in such a way that only big O of n log n solutions would pass, if you have tried to code O of n square solution using insertion sort or something, your solution may not pass. So let's talk about what is optimal time complexity and what is suboptimal or brute force solution. So a brute force solution is a solution which can solve the problem. It always gives the right answer, but may not have the optimal time complexity. So when we talk about time complexity, generally less is better, right? So if we have two solutions, one is O of n square for sorting and one is O of n log n, we would prefer to use the O of n log n solution, assuming that as n grows larger and larger, it's best if we have the n log n solution, so that like it will perform well for larger n. So what we do is, if we have a coding question in which the constraints are such that uh, O of n square solution is called the brute force or slow solution. So we try to set test cases in such a way that such brute force solutions don't pass, and optimal solutions are those that have less time complexity. Or sometimes it's even possible to prove that, if you are given some problem like sorting, which is well understood. So we even have bounds on what kind of solutions are optimal for this. So optimal means we can theoretically prove that for solving this question faster than this much time complexity is basically impossible. So such proofs are also there. So optimal time complexity generally means less time complexity, and especially if in some problem it's possible to prove that this is the minimum time complexity possible, so that's called optimal solution. And as I explained, so any solution that comes to your mind which can solve the problem, I does not give wrong answer, that's called a brute force solution. And sometimes it's possible that the brute force solution may itself be the optimal solution. So let's say if you are given some tree question, and let's say you have to do in order traversal of the tree, and for that you have to visit all the nodes exactly once, and that's O of n, and you can call it brute force, but that is optimal solution also. So sometimes brute force solutions may be optimal solution, but you have to start recognizing your brute force solution and how you can optimize it and so on. So if you get a naive or brute force solution, try to think of some data structure algorithm which can reduce its time complexity. So generally what would happen is, if your code has some if your solution has some sort of redundancy, you can use some kind of map. Or if you are let's say using some property in which you have last in first out, so you can think rather, so if you have some problem which is, let's say, of strings, and you are using something which has last in first out property. So based on that, you can realize that, last in first out means stack, so we should use stack to solve this question, and so on. If you are solving some question which has simulation of something, of some time parameter in which, things are going in a queue or something, so based on that you can realize that this uses queue, so queue might be the best way to solve it, and so on. So similarly, if you try to recognize what is the data structure algorithm using which we can solve this problem in less time, so that will give you the optimal solution. Now, expected time complexity. So often in the coding test, the problem setters give constraints such that which the constraints themselves hint towards the expected time complexity of the solution. So online coding platforms like CodeChef, HackerRank, etc., your code would take 1 second to do 10 to the power 8 basic operations like add, subtract, multiply, divide, etc. Which means if you are able to do 10 to the power 8 operations in 1 second, it means that if your n is up to 100, you can go up to n raised to 4, because te- yeah, n raised to 4, because what happens is 100 raised to 4 is approximate is 10 to the power 8, which means it can pass in 1 second. Then if your n is up to 400, you can do O of n cube. But if let's say if n is up to 1000, and if you try to do O of n cube solution, what will happen is n cube will be 1000 cube, which is 10 to the power 9, which is larger than 10 raised to 8, which means your solution won't pass in 1 second. So then next is if n is up to 2000, so n square log n solution would pass, because for 2000 what will happen is n square log n will be about 2000 square, which is 4 into 10 to the power 6 into log of 2000, which will be just slightly less than 10 to the power 8, which means n square log n would pass. And then if you have n up to 10 to the power 4, i.e. 10,000, n square solution would just barely pass, because 10,000 square is approximately 10 to the power 8. So yeah, I think it would be just on the border to pass. And then if you have n up to 10 to the power 6, or you can just have n log n solution which can pass, or O of n. And if you have n going up to 10 to the power 8, usually they expect O of n solution, and if n is larger than 10 to the power 8, which you can see sometimes in maths questions and so on. So if n is going up to 10 to the power 18, they are expecting O of log n or O of 1 solution, because log of 10 to the power 18 is like of the order of 18, so it will be quite small. So O of log n or O of 1 solution can pass. So, and yeah, you don't need to write down this table. This table is given in the hacker earth link that we have given for the time complexity thing, so you can just check it out. And then if your code has a complexity of O of n square, it can work for inputs up to size 10 to the power 4. Beyond that, it would exceed the time limit. So if the constraint says n is up to 10 to the power 5, O of n square algorithm is not going to work. So they are expecting an O of n log n or O of n solution when n is 10 to the power 5. So you should try to optimize accordingly. In such a case, you have two options. You can either code the algorithm as it is, or try to optimize it using some other data structure algorithm. If you decide to code the algorithm as it is, what happens is in certain websites like CodeChef, HackerRank, HackerEarth, etc., you can also get partial scores, which means your solution would get a score based on how many test cases it passes, right? So let's say on HackerRank we have 30 test cases, out of which your solution passes 10. So you can get 1/3 of the maximum score, or however the scoring system has been set up. So even if you can't get the optimal solution, try to code whatever solution that you have, so that you can at least get some partial points rather than just getting a zero. So always getting some partial points is better. And if you cannot optimize your code, it's just best to submit it as it is. And let's say usually what happens is in such coding questions, if you get a optimal solution later, you can always go and resubmit, and you can get more points later. So yeah, this is how it works. And generally what happens is in most of the contests, if they have different scoring for different problems, what happens is the questions which are easier, which have less score for them, and questions which are tougher, have more score for them. So you can start solving from the easiest question to the toughest, and for easier questions you can try to get more points, and or like full points, and for a tougher question you can try to get some partial points. This will help you improve your performance. And then let's talk about language and STL. So most of you, I think, I think all of you would be knowing C programming language, which is part of your curriculum in first year. So from C you can switch to C++ easily. Also in companies coding tests, they will ensure that the questions are solvable using C++ and Java, but not necessarily Python. In our DSA learning series also, we are focusing only on C++, and some problems may not be solvable using other languages like Java or Python. This is because they are too slow. So we will ensure that the questions are solvable in C++, but in other languages they may or may not be solvable. As a general rule of thumb, you can think that Java is 2x slower than C++ and Python is 10x slower than C++. Hence, if the constraints are lower, you may be able to solve the question using Python or Java. But if the time limits are strict, then solution would pass only in C++. Also in C++, we have a rich set of library tools which are called STL, Standard Template Library, which you should definitely check out. So we have also shared a few resources on learning STL, and you can check them out. So what is STL? So STL is a set of library that comes with C++, and you can directly use it on your computer. So I think it's already there in the latest G++ compiler, or Clang if you're using a Mac. So definitely try to use. Yeah, another thing about compilers, so please try to stick to G++ or Clang compilers. Please don't use Turbo C++ or any Borland C++ or older versions which people used to use with DOS. So please try to move to Linux and use G++ on Ubuntu or Mac. So that will be a good thing to start. And then we are talking about C++ STL. So in C++ STL, we have things like vector, stack, queue, map, set, etc. So what happens is, if you are using C++ STL, you don't have to code stack or queue or map on your own. You can just directly use them. And vector is like a dynamically sized array. So in arrays, if you know, we have fixed size arrays, right? You can fix some size 10 to the power 3 or something, which will be its maximum size. And if you want to store more elements into the after declaring it, you will not be able to do it. But if you have a vector, you can like increase its size dynamically. You can just keep pushing elements and it will work. And for stacks and queues, what happens is, they have so you don't have to do pointer things, and you don't have to make the stack on yourself basically. So you can use C++ STL, and we have shared resources on them. And then these STL tools are really helpful in solving questions, so that you don't have to code them yourself. And definitely, so what will happen is, as we will increase the difficulty level of the contest, and even in companies coding tests and all, they will usually set problems which are not directly implementation of stack and queue. They will have some application, and to solve application based questions, if you spend a lot of time implementing stack yourself, that will be a lot of waste of time. So I think it's best if you use C++ STL things for that. And then let's move on to the next thing, memory limit. So in online coding platforms, you can allocate an array of size up to 10 to the power 6 integers. If you try to allocate more, you may not be able to, and your solution would get a memory limit exceeded verdict. I think memory limit exceeded happens very rarely, but sometimes it can happen. Then next is edge cases. So sometimes your solution would get a wrong answer verdict. So wrong answer can be due to overflow or failing on certain edge cases, etc. So let's say if you are solving a stack question, but your solution does not consider a case where the stack is empty, you can get a wrong answer or runtime error. So if your stack is empty, but you have not thought about it, or you have not written a if condition which handles what happens if the stack is empty, so you can get a wrong answer. Or if you're trying to access the top of the stack which is already empty, you can get a runtime error, because that's an error in C++. I don't know about other languages. So this is how it works. And then to solve such errors, it's best to dry run your code. So let's understand what is dry running. Dry running means you try to run your code on pen and paper. So you try to simulate your code on pen and paper on certain input, and see what it does for input, and where it uh, how it works, and so on. So dry running is the best technique which we use to debug our code. It also helps you think through your solution more rigorously, so that you can find where are the bugs and such things, or where is redundancy, you are computing something again and again and so on. So that's dry running. And also, if you have an IDE which has a debugger, you can try that too. So then we have a few IDEs like Eclipse, and there is CLine which support such debugger, so that you can use them. And also writing a lot of tests for edge cases helps, like what happens when your array is of size 1 or 2 or too large or so on, or some particular string pattern, like if you are solving some string question, and if your string has some particular pattern like A or AB and so on. So what happens in such cases? So those are called edge cases. And then let's learn about what is integer overflow. So in C++ and Java, int is a 32-bit integer data type, meaning it can hold values from int min to int max, which roughly means minus 2 into 10 to the power 9 to 2 into 10 to the power 9. If you try storing an integer which is not in this range into an int, you will get an integer overflow. It can happen due to addition, subtraction, multiplication, etc. So then please check out this link on integer overflow. If let's say x is 10 to the power 5 and x is an int, and if you try to do x times x, you will get 10 to the power 5 times 10 to the power 5, which is 10 to the power 10. This is outside the int range, and you will get an overflow. In such cases, it's best to use long data type in C++ or long in Java, which ensures that these door overflows don't occur. So long and in C++ and long in Java are 64-bit data types, and they can support a range of minus 4 into 10 to the power 18 to 4 into 10 to the power 18. And if you need to store an even larger integer, which is beyond 10 to the power 18, probably you should switch to probably you should switch to Python, because in Python the integer does not have a limit, and it can store arbitrarily large numbers. Or you can use begin class in Java, or you can store the numbers as strings and code your own plus, minus, multiply, divide, etc. operations on them. And yeah, I think it's sometimes you should code such questions in Python, especially if there are some maths questions which just use large integers, and other than that they don't have any other complications. You can use Python. And then for last topic that I would like to talk about, recognizing patterns. So for solving DSA coding questions, mugging or remembering solutions is never going to work. So the main motto of our learning series is to improve your DSA skills by making you start recognizing patterns in the questions. By reading the question description itself, you should be able to figure out whether this uses stack or queue or just array, etc. Once you start recognizing such patterns, you can solve almost any question. Often, the DSA coding questions that you will see will also have a story in it. So you will have to read the story, translate it into an algorithmic problem, and then start recognizing patterns in it. There are a few standard questions for each topic which we have tried to add in the practice questions list that we sent on the Facebook group. And such as for stacks, we have expression parsing, bracket matching, stock span problem, etc. Once you solve all such standard questions, it should be easy to find patterns in new questions and reduce them to some such standard question. To recognize patterns, dry running, as we discussed above, and solving more questions are the only two ways. And if you try to solve more questions, as well as if you dry run your code, you will be able to recognize patterns, and you will be able to find what is the optimal way to solve your question. So with this, best of luck, and try to solve try to go through all the reading material that we have sent, and solve all the coding questions that we have sent. There are, I think, around 10 per topic, and ask the doubts on the group. And thank you.